And this was so funny. Did you understand the part of my presentation where if you take the
God.
angular resolution limit of the eye and you reverse engineer it, you get the exact radius value of the
I
globe?
saw you say that, and I'd love for you to run through that math for me because I
Okay. And then you're going to
guarantee
concede. And then you're going to concede
I'm going to concede. Yeah, I'm going to. What am I going to concede?
that
Let's run through it.
if you take the angular resolution limit of the eye,
Mhm.
right, that you can get the radius value of the Earth to the exact decimal place.
Sure. Well, I want to see what you're talking about because it doesn't even make sense.
Okay. But whenever I show you, you're going to say it's just a coincidence.
Oh, you're
I'm
welcome
pulling it
to.
up. All right. The angular resolution limit of the human eye is about 1 arc minute, or approximately between zero point zero 0.02 and zero point zero 0.03 degrees. Optical information loss occurs when the angular size of an object is smaller than the angular resolution. This angle at 0.0217062 degrees and an assumed light wavelength of 666 nanometers,
The
you
devil.
can derive the radius of the Earth. If you look here, the horizon gain for a 6 foot observer across that amount of degrees was inverted as height information loss across the same angle. And the two angles were used to construct a sphere or globe with a tilt angle of 0.0434124 degrees, which is just the first amount doubled, right? So then what you would get, this angle represents the 6 foot drop from a 6 foot observer across the average horizon distance of 2.9 miles. The depiction here is the easiest way to understand it. Either A, we're losing information in the distance because the angle of view in relation to the tangent is actually falling below the resolution limit, so you lose resolvable information, or it's doing that at the same exact distance because the Earth is a ball. So what a coincidence that the angular resolution limit of the eye that tells us that we'll lose resolvable information, right, can be used. That same ratio will give you, if converted to assumed spherical physical obstruction, will give you 3,958.8 miles.
I'm sorry. Did
So
you have something in here that showed us what the calculation of the radius from the angular resolution is?
yeah, sure. Here you go, right here. So if you look at you, we just covered the angles, right? You got the angular resolution limit of the eye, right? Okay. So if you look at the formula here, you have quote unquote the way that you would get the radius of the Earth. You assume that the information loss is actually because of a physical obstruction as opposed to resolution. So you would just make that assumption. You would say, for example, you'd go out onto the ocean and say, look, the boats disappear at 3 miles for a 6 foot observer. A, it's because the boat's getting down below the eye's resolvability, or B, because the Earth's a ball and it disappears around 3 miles. Okay. If you assume it's the latter, and it's because the Earth is going behind the curve of the Earth, then you would take the radius of the Earth and you can take distance divided by the tangent times twice the angle, the theta, the viewing angle, right? And so when you do that, then you now get 2 theta, which is 0.0217062 times 2. So you get 0.43412. The distance equals the distance to the horizon, which is 2.999547. These are the values that come from the eye, the human eye. And then wait up. It's so wild to me. I think it's wild. So when you actually take those values and you plug it into that formula, which is right here, again, radius of the Earth equals distance divided by tangent times twice
How do we
theta.
get that formula?
What? Right here?
No, I didn't ask where it came from. How did you get it?
We just covered how we got it. We just covered how
No,
we
we
got it.
didn't.
We did though. So,
No, we
so
didn't.
the angular resolution limit of the eye, right?
No, I didn't ask you what the angular resolution is of the eye. How did that? How was that formula derived?
Because what that shows you is that the information, meaning the visible light, the information is going to start to fall below resolvability at a certain distance based on a certain height. That's what the angle does, because theta, the viewing angle relative to the information, the distance of the eye, shows you when the information is going to fall below the resolution angle. It's actually based on propagation and reception angles of what you're viewing with billions of points of light or whatever. Nevertheless, if you assume, okay, well, actually, the curve of the Earth is blocking something, so it's a physical obstruction that causes the loss of information, you can take that same relationship, flip it around, and coincidentally, if you do that, then you will actually get a radius value of 3,958.80786746061 miles. Now go Google the exact radius of the Earth, and what's going to tell you is 3,958.8. So now this could just be a coincidence, but let's
Maybe
use
it's
our
a
brain.
coincidence. Maybe it's a
Let's use our
coincidence.
I knew
Maybe.
you. Okay, it's a coincidence theorist, but let's use our brain for a second. Now, people back in the day, they didn't have very good optics, right? So they went out there. I'm gonna stop sharing. They went out into, say, look at the boat or whatever, right? And then it disappeared. They're like, man, why does the boat keep disappearing? If they were trying to think about if the Earth was a sphere, they'd be like, the boat's going behind the curve of the Earth, reasonably, right? So they'd be like, well, it pretty consistently disappears around this distance. If you assume it's going behind the curve of the Earth, then you would get that value because if it was your eyes, right, it would continuously fall below resolvability at that distance, right? And so you'd be like, oh, but you would think that's because of the curve of the Earth. Now, what has happened since then is we pulled out binoculars and telescopes and cameras, and you can bring the boat back. Objectively, I've done it hundreds of times. This is just a fact, okay? If you go out and you look with your naked eyes, it'll look like the
Mhm.
boat disappeared behind the water. And if you pull out a camera, you will see that boat again, okay? So
Show it.
that means when Aristotle supposedly in 350 BC said he looked at a boat and it went behind the curve of the earth and he didn't even have a telescope. He had no idea what he was talking about. If he had pulled a camera, he would have saw the boat again. Now, coincidentally, the very distance that it would fall below the resolvability of an average height of a man, 6 foot observer, that's where the radius value comes from. Do you think it's just a
Mm.
coincidence?